Let us solve a numerical example, and this example will help to make a picture in our mind clear about the concept which we have studied in previous lecture of multiple conductors and capacitances. So let us see what is the example. So we will take our favorite parallel plate capacitor. This is plate 1, this is plate 2, and we will assume that it is inside a box, metallic box, and this metallic box is grounded, and this distance is r, this distance is s, and this distance is t. Now we want to find the capacitance matrix in this scenario, that is q1 is equal to c11 v1, c12 v2, and q2 is equal to c21 v1, c22 v2. So according to the definition, c11 is simply q1 over v1 when v2 is equal to 0, and c12 is equal to c21 is equal to q1 over v2 when v1 is equal to 0, or q2 over v1 when v2 is equal to 0. So now we will calculate these coefficients, and we will try to see where our picture of parallel plate capacitor fits in. So let us say that in our picture we will take this parallel plate capacitor. This is plate 1, this is plate 2, and this is metallic enclosure which is grounded. So we will ground this plate 2 also. This is R, this is S, and this is T. So we will assume that this is charge Q1, this is charge Q2, and this is potential V1, and this is potential 2 V2, which is as of now 0. So we know that the field in this area, if let us say I call it as ER, and this is ES, and this is ET, we can clearly see that ET is equal to 0, because this is at 0 and this is also at 0, so there is no potential difference, so there cannot be any field. Now we will try to find what is the value of ER and ES. So we will make a Gaussian surface like this. So you see the total charge enclosed is equal to ER into A plus ES into A, or ER plus ES into epsilon naught is equal to the charge Q1, the total charge Q1. So Q1 is equal to A epsilon naught ER plus ES. Now you also see that ER is equal to simply V1 over R, and ES is equal to V1 over S. So I will put this value. So Q1 is equal to A epsilon naught V1 over R plus V2 over S. So Q1 is equal to, I will take this thing like A epsilon naught over R, it is also V1 not V2, and V1 common 1 by R plus 1 by S. So we will proceed in the next slide. So you see that Q1 over V1 when V2 is equal to 0 is simply A epsilon naught 1 by R plus 1 by S. Now we need to find C12. So C12 similarly will be the charge Q2 over V1 when V2 is equal to 0, or Q1 over V2 when V1 is equal to 0. So again we will take our previous case only, when this plate 1, this is plate 2, this is at V1 charge Q1, this is charge Q2, this is V2, and this is let us say grounded, and this is the metallic enclosure, and this is R distance, this is S distance, and this is T distance. So we will try to now find, so this Q2, so field ES is equal to the charge Q2 over epsilon naught into A, or ES is equal to, or Q2 by A epsilon naught. If this is charge Q2, so by again Gaussian surface we will make, here the field is 0, only this surface will contribute. So ES rather minus sign will become, because ES we have taken in this direction and normal is in this direction. So ES minus sign A epsilon naught is equal to Q2. Now we also know that ES is simply V1 over S. So we will try to find C12 is equal to Q2 over V1 when V2 is equal to 0, and this will come out to be minus ES A epsilon naught, and I will put this value as V1 over S, and I will divide by V1, this V1. So I will get C12 equal to minus A epsilon naught over S. So in this way we can see that C11 is equal to A epsilon naught 1 by R plus 1 by S. C12 is equal to minus A epsilon naught over S. Similarly, C12 is equal to C21, so it will be minus A epsilon naught over S. And C22, by the similar method, we can find out as A epsilon naught 1 by T plus 1 by S. Okay, so this is the coefficient matrix. Now let us see what is the relation between the parallel plate capacitor and our this matrix. So in the parallel plate capacitor, what is actually happening is that this is S and this R and T are going to infinity, because there is no grounded enclosure. The ground is at infinity. So you see that C11, when I will put this limit R tends to infinity, will remain as A epsilon naught over S, and C12 will again remain minus A epsilon naught over S, and the C21 again minus A epsilon naught over S, and C22 will be A epsilon naught over S. Now still we are having four factors. Now how to get the correlation between the normal parallel plate capacitance and these factors? So what I will assume that this is at potential delta V by 2 and this is at potential minus delta V by 2. So the charge will be Q1 C11, the potential of the plate 1, plus C12, the potential of the plate 2, and I will put the value now. C11 is A epsilon naught over S delta V by 2, and this will be C12 is minus A epsilon naught over S, and this is minus delta V by 2. So you see that Q1 is now A epsilon naught over S delta V by 2 into 2. So this is A epsilon naught S delta V. So the potential difference between these two plates V12 is actually equal to delta V. So according to the definition of the capacitance between two conductors, we have Q1 over V12 equals to Q1 over delta V equals to A epsilon naught over S. So this is the same which we calculate for a parallel plate capacitor. So you see that actually this C12 or C21 are related to the capacitance which we actually calculate, and these self coefficients are usually related to the factor which we calculate when we consider that these conductors are kind of in isolation, but it may not be 100% true. So in this sense we can make a small picture in our mind that if let us say these are multiple conductors, so this is capacitance, this is conductor 1, this is 2, this is 3, C12, C13, it is C23, C13, and this is C1, this is C2, this is C3, and this is ground. So we can make a picture in our mind that C11 is actually equal to C1 plus C12 plus C13. This is the capacitance which we actually are habitual of. This is the capacitance between the conductor and the ground. This is the capacitance between conductor 1 and 2. This is the capacitance between conductor 1 and 3. And C12 is simply minus of C12. So in this way we can make a picture in our mind between these various coefficients which we have seen in the matrix and the real capacitance which we are used to in various calculations. So if you find that this lecture is helpful to you, then please share and subscribe our YouTube channel, and also join our Telegram group whose link is given in the description of this video. Thank you.